In this video, we are going to do a two-dimensional kinematics problem where the object is moving in an arc as it is moving through the air. So in this particular case, we have a Navy railgun firing a shell at 3,000 meters per second straight out, 23 meters above the surface. We need to find the range of the shell and need to find the height of the shell after traveling 3,900 meters downrange. So this is my boat because it's a Navy railgun. A railgun is able to accelerate things to insanely high speeds of 3,000 meters per second. It is being fired straight out, so that means it is going to start level as it comes out, and then it is immediately going to arc down. The starting height is 23 meters above the surface. We know the starting velocity is 3,000 meters. This 3,900 meters we'll deal with in the second part of the problem, so I'm not putting it in the drawing. Because this is two-dimensional, we have to the right and we have vertical. I am going to split the problem. I'm going to do my x stuff and my y stuff. So my original x, my final x, my original speed, my final speed, my acceleration, and my time. In the x direction, I start at 0x. I don't know where I end because x final is what we call range. My original speed is 3,000. My final velocity is still 3,000 because we are going this way. And I know this because my acceleration is 0. This is horizontal acceleration. There's nothing going this way. And we don't know the time. Now vertically, I start at 23 meters. I end on the ground. My original speed, we'll come back to that because I don't have one. It is not 3,000 because I am not going down 3,000. My final speed, I don't know. My acceleration is negative 9.8 meters per second squared. And the time, I don't know. So my original speed, this is what is called a horizontal launch. I am being thrown directly sideways. So my original vertical velocity is 0. So let's put that as a y. Because I want to have these labeled as x's and y's because these are not the same. So that's my acceleration in the y and my acceleration in the x. So one thing these things do share is my time. This is the #1 strategy for solving trajectory problems, is to find the time something is in the air. So I'm going to go with the y-axis to find when it hits the water. I'm going to take a look at my 3 equations here. I need time. I don't know final velocity, so he's not going to work. Vvax doesn't have time at all, so I'm going to use him. So it's going to be yf equals 1/2 a y times time squared plus v naught y times time plus y naught. All y's because I'm doing my vertical one first. #1 mistake is you guys grab horizontal stuff and put it into a vertical equation and you mix things up. Don't do that. All right, so yf is 0 equals 1/2 of negative 9.8 times time squared plus v naught, that is 0 times time, with a y naught of 23. So 0 equals negative 4.9 t squared plus 23. So this gets me negative 23 divided by negative 4.9 equals t squared. Let's go ahead and just rip both of those. And we get 2.1 seconds is my time. This is how long the object is in the air. So to figure out the range, let's go ahead and just update these. It is the same for both of them. So I can come over here. I want to find my xf, and I now have the time. So I'm going to grab this same equation here. It is now xf equals 1 half at squared plus v naught xt plus x naught. This is going to be xf equals, this whole thing goes away because I have no acceleration. 3,000 times my time of 2.1 plus my original position of 0. And I get a final position of 6,300 meters. Now, if I want to find where I am at the 3,900 meters downrange, I have to tackle this problem a little differently. I need to know how long it takes to get to 3,900 meters. So when I fire the shell, so here's the shell, it goes this way. Here was the 6,300 meter mark. I wanted to know what is the height here at a distance of 3,900 meters. We know it's got to be less than 23 meters, but not how much. So we're going to figure out how long does it take to get here. Well, this is a horizontal motion. So my position is equal to 1 half at squared plus v naught t plus x naught. We're going to put in the x numbers. My final position is 3,900 equals 1 half. Actually, this whole thing is 0, so we get rid of it. 3,000 times t plus 0. So I get 1.3 seconds is my time. I can then go into my y-axis. YF equals 1 half at squared plus v naught t plus y naught. Let's make sure I use the y numbers. I don't know this, but this is going to be my negative 4.9 times 1.3 squared plus, this is 0 this time because this is vertical. You can check the givens on the earlier in the video. And my original height was 23. So I'm going to get YF is equal to negative 8.28 plus 23. YF is equal to 14.7 meters. Remember the key for doing these problems. Automatically split things into the x and in the y components and make sure you keep your variables straight. Do not use a horizontal speed in a vertical setup. The only thing that can be shared between the two is the time.